Hello and welcome to Maths with Jacob. This lesson will focus on using coordinate geometry, part 1. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. Coordinate geometry is a very powerful tool which can be used to demonstrate many properties of various geometric shapes. Example 1. Prove that the following triangle is right-angled. So here's our triangle A, B and C with the 3 coordinates, and here's the solution. If we can show that 2 of the lines are perpendicular, then the triangle is right-angled. Let's have a look at the slope of AB, which is this one here. So that line there from A to B, let's have a look at that slope. So the slope of AB, as we remembered from previous videos, y2 minus y1 over x2 minus x1, which is 4 minus 1 over 0 minus 3, and that's negative 1. So the slope of AB is negative 1. Now let's look at the slope of BC, which is from there to there. Similar formula. So it's 1 minus minus 4 over 3 minus minus 2. When we simplify that, that works out to be 1. So one of the slopes is negative 1 and the other slope is plus 1. Since the product of the 2 gradients equals negative 1, the triangle is right-angled. Of course, we saw in an earlier video that if 2 lines are perpendicular, the product of their slopes is negative 1. Example 2. Prove that ABC is an isosceles triangle. So there's ABC with the points. We need to prove that 2 sides of the triangle are the same length. Now here's the distance formula, which we've seen many times before. Let's try and find the length of AC, which is from there to there. So we're using the points 2, 1 and 5, negative 3. And we substitute those points into the formula. We do our simplification and we find that AC has a length of 5 units. Now let's find the length of AB using those 2 points. So we substitute the points into the formula and we do the simplification and we find that the length of AB is 5 units. So since AB equals AC in length, the triangle is isosceles. Example 3. Prove that the origin is the midpoint of AB. So there's AB. We have to prove that the origin, which is 0, 0, is actually the midpoint of that interval. So here's the formula for the midpoint. We substitute the 2 points in. That's negative 5, negative 2 and 5, 2. So you substitute those in and you see that the midpoint is 0, 0 and that's the origin. Now we can ask the question, what is the equation of the line passing through C and the origin? So if you have a line from C through the origin, what's the equation of that line? Now all you do is use the 2-point formula. Here it is here. We've seen that many times before. And here are the 2 points. So x1, y1 is negative 4, 4, which is there. And x2, y2 is 0, 0. We'll let that be the origin. So you substitute all those points in to get to this line. Some simplification to get us to that line. Some cross multiplication to get us to this line here where the red arrow is. And lo and behold, when we simplify that, the equation of the line passing through C and the origin is x plus y equals 0. Here's a quick quiz to help you. Please check through the video at any time. The answer to the puzzle, what is the meaning of the following? Go for it! I love that one. I wonder if you got it. And here are the answers to the quick quiz, and the video is at your disposal.